Here are some problems you're going to have in the homework that become important to know for other problems. These are not very difficult. And here's another case where you can use the unit circle, although a lot of these you can just hopefully figure out in your head. So here's the kind of question you're asked. Find the quadrant for theta. So here's an example where find the quadrant for theta where cosine of theta is greater than 0 and sine of theta is less than 0. So basically, you're starting out this problem with an angle, a specific angle. You don't know quite what the angle is, but they do give you some information. They say the cosine of that angle is positive, right? So greater than 0 means positive. And the sine of that angle is negative. So here's how I go about solving this problem. So just to review, right, quadrant means we go counterclockwise. These are the 4 quadrants. So they want to know which quadrant this angle is in. Now this one I'm just going to do common sense, although in a minute I will show you how you can reference the unit circle to do it. Although hopefully some of these kinds of problems you can just think through them. If you think about the x and y axis and you think of points in the quadrants like x and y, in quadrant 1, what is x going to be in quadrant 1? X is always positive in quadrant 1. What is y? Y is always positive. Well, we talked about with the unit circle, the x is always like the cosine, and the y is like the sine. So basically, if we're in quadrant 1, the cosine's positive, the sine's positive. If we go to quadrant 2, what is x in quadrant 2? X is negative. What is y? Y is still positive. Therefore, in quadrant 2, your cosine is negative and your sine is positive. We go to quadrant 3. What's going on in quadrant 3? Actually, x and y are both negative, which means the cosine is negative and the sine is negative in quadrant 3. And in quadrant 4, x is positive now, y is still negative. So in quadrant 4, the cosine's positive, the sine's negative. So with that information, let's go back to this problem. They're saying the cosine is greater than 0. The cosine's positive. What are the quadrants where the cosine's positive? Well, the cosine's positive wherever x is positive. And that's in quadrants 1 and 4. So normally, I just go up here and I put the possible quadrants. For the cosine to be positive, I'm either in quadrant 1 or quadrant 4. And that's because x is positive in quadrant 1 and quadrant 4. But then they also say, at the same time, the sine of theta is negative. So which are the quadrants where the sine is negative? Or you could say, which are the quadrants where y is negative? Well, it's in quadrants 3 and 4. So from this piece of information, the angle has to either be in quadrant 3 and 4. So then you compare these two, and you see what you have in common. Well, They both have quadrant 4 in common, so the answer has to be quadrant 4. In other words, these two trig functions, each of them on their own, narrow it down to 2 quadrants, but then when you combine the information, it actually narrows it down to 1 quadrant. Let's do another one that's pretty straightforward. What if we say cosine of theta is negative and sine theta is negative? So actually, cosine and sine are both negative. So if I think about my quadrants, cosine is like x. Which quadrants is x negative? Well, quadrants 2 and 3. Now I'm also at the same time saying that the sine of theta is negative. Which quadrants is the sine negative? It's like y. Well, y is negative, or the sine's negative in 3 and 4. So what do we have in common? Looks like quadrant 3. And it sort of makes sense. Look at this little thing. This is the x and the y. Cosine and sine, look at, they're both negative. This first problem, cosine positive, sine negative. Cosine positive, sine negative, quadrant 4. Now, that's sort of the common sense way to do it, but if you're sort of lazy and you go to this unit circle, it's in fine print, but they sort of tell you for quadrant 1 of the 6 trig functions which ones are positive. And actually in quadrant 1, they're all positive. You get to quadrant 2, here are the positive and the negatives. Quadrant 3, quadrant 4. You can use this if you need to, but really you should be able to figure these out just with common sense. Let's do a little trick here. How about if I say cosecant is greater than 0, positive, and let's say the tangent is negative. Now think about cosecant. Cosecant is paired up with the sine, right? Now when you're looking at plus and minus, cosecant and sine are the same. So when I see cosecant is positive, in my head I'm thinking, where is the sine positive? The sine is positive in quadrants 1 and 2. The tangent, now tangent's a little tricky. I'm sorry I miswrote this. Hopefully you caught that. I want the tangent to be negative. Here I use the fact, what we learned a little bit ago. Let me write it down here. Tangent is sine over cosine. So you know what? If I want the tangent to be negative, you know what has to happen? One of these has to be positive and one negative. In other words, sine and cosine cannot be the same. Because if they're both plus, then the tangent's plus. If they're both negative, then the tangent's still plus. So it has to happen where the sine has to be positive and the cosine negative, or the sine negative and the cosine positive. So what are the quadrants where x and y are opposites? Well, right here, cosine's negative, sine's positive, so quadrant 2, and looks like quadrant 4. So for the tangent to be negative, has to be quadrant 2 or quadrant 4. So now when I compare these, what do they have in common? Quadrant 2. So this is a little exercise that it may not quite make sense to you now why we're doing this, but in future problems, it's going to become very important when you start out the problem. Sometimes one of the first things you do is you're given information about an angle, and you need to know which quadrant that angle is in. And one of the first things you will do is use this kind of information to decide which quadrant the angle is in, because that's going to become important when you start working up your answers to the question.